社も出てくると思うよ。そうだね。
White light model, and we do have laser-based model. What this does is it allows us to pick up color and texture with the white light. It's great for reverse engineering. It's a 50 micron accuracy. When we get into the laser-based ones, we get up into we could go up to 25 to 20 micron accuracy depending on which scanner it is. But as you can see, it picks up the surface really well at 1.3 million measurements per second.
Wow.
So if you think about that with a CMM, just put that into perspective, right? CMM, 1.2 million points. You know, how long would it take you to actually probe that?
How far can you go away from the object?
So it does have a standoff distance.
Right.
Right. As far as the size of the part, and we're still scanning this far away. As far as the size of the part, you know, these scanners have the ability to scan very large parts. It just comes down to accuracy because it's not linear.
Right.
It's going to fall off non-linear after about 20 feet of the scan that were my actual arm. I'm going to go ahead and clean this up a little bit more and then get rid of the rest of it. And what you see, what I'm creating here on screen is an STL. Okay?
Oh, right.
So as far as file types, that's something we can go and throw right on a 3D printer. What do you guys plan to manufacture? Right. We can go through a piece of software called VX Model, where we can start extracting information off this and throw it back into SolidWorks. Right? It's very simple. For example, this is injection molded, right? So this cylinder in here, and this cylinder in here, and a couple of these, they're actually cones because they have draft on them, right? So we're going to go ahead and we're going to choose the cone option up here. We're going to help the computer extract the geometry out of it. Alright? So I'm just going to quickly click on that, and I'm going to tell the computer to look over here and extract a cone. And as you can see, it's exactly what it did. It looked in that region and it extracted a cone to very high accuracy. So I like what I see. I'm going to go to the next one, repeat the process, maybe grab a few more on the outside. You can see the algorithm building those codes. So now that we grabbed a few pieces of information, I'm going to stop here. I'm not going to go through, make you watch me go through the whole thing. I have this transfer to SolidWorks option right up here. Okay? And that's going to do a live transfer of the items I just created over to SolidWorks.
Wow.
So that's what I did. I selected the items, and there they are. They popped in over in SolidWorks.
DXF file or?
Hold on a second. I had it. Hold on. I stuck them in the same session as I did before. I just showed somebody something before, so I put it in the same session. So I had to get rid of that one. Reset it back over. There we go. So these are the codes that I selected, and they are parametric, which means I can go in here if I ever wanted to, and I can edit them. So we do have those dimensions, those editable dimensions, and you can see it is parametric. So, I can reverse engineer it. I can make adjustments off of it. And I can go back in here and extract more information and send it back over. Questions?
How much is it?
So this particular one is about 40K.
Okay.
And it goes up and down from there depending on the accuracies and what applications you're trying to apply. We do inspection too, so first article inspection, PPAP inspection. You can upload the CAD, scan the part, lay it over, and spit out a first article.
Hi, how are you?
Good. How are you?
So, have you seen this before?
Over there.
Yeah.
Stratus.
Go scan or whatever.
Yeah.
This is the Metro scan. The Black Elite. We have 14 crisscrossing blue laser lines. They're going to pick up that dark and shiny part easily. As you can see, if I just go over the top, it has no problem reading that whole space. Even with all the reflection and lights and everything going on.
Right.